right. Hello, everyone. How's everyone doing?
Yo,
Yo.
that's all I
Welcome
got.
to the Tech Audio Chat. This is what we want. We want people who like the introduction. They feel like they're being introduced to the thing. For people who've been here before, which is I think everyone, welcome back. And if you're new, welcome. Just regular welcome. Just like classic. Default welcome. This is the Tech Audio Chat where we hang out and chat while being tech audio people. I don't know what that means. We do tech audio stuff. We do it in front of you before your very eyes.
What is tech audio?
What is tech audio? No one can no one can be told what tech audio is. They have to
It's
be
whatever
shown.
you need it to be at the time.
Yeah, so hi, I'm Dan Reynolds. I'm currently a senior technical audio designer at Epic Games. What that means is something that I am constantly learning about.
It's a mystery.
It's a mystery. And I'm joined by Eric Buchholz, and he can introduce himself.
Yeah, I gotta update this. It's like, I'm Eric. I am a technical audio designer currently at Epic Games. I used to do music and orchestration for games, TV, films, concerts, albums, the works, and now I'm doing tech audio because I'm crazy.
Yeah, it's fun. I like tech audio. I mean, it's okay. This is actually something that came up. I don't always consciously think about it, but it was something that came up in a conversation recently, which is like one of the joys of doing like scripting and coding. I found is being able to listen to music.
Yeah,
It's like
it's
the
a perk.
hardest. It's like the hardest part about I for a long time I did music production. Like I was like did a lot of subcontracting, like MIDI like virtual instrument programming, and I've done kind of everything: sound design, dialogue, etc. And what always is like the toughest part is like I can't like if I'm in the middle of some operation, especially most of the time having some kind of critical listening is
Yeah.
required, and I can't just have tunes on in the background to enjoy.
Yeah,
I
it's like
love
your ears
music.
are busy the whole time. Like,
Yeah.
yeah.
That's like the hardest part about like monetizing one of your passions.
Well, yeah, it's a trade-off for sure. I mean, there's still many days where doing tech audio work, it's like you still have to listen. I would
Yes.
say
Yeah.
at least half the time. You're hearing what's happening.
Yeah. It depends on what part of the thing
I
you're
guess
working on, right?
it's not always that.
Yeah. I mean, if it's like functionality, you got to test the functionality. But sometimes even your test content is not necessarily like if you're building a system, sometimes you just need like test content that is not necessarily design. But then of course there are implementations that are very design heavy, and the outcome is something that you want to sort of critical listening for.
Yeah, one thing. So lately, I've been. I feel weird saying this after what I said last week. Is I've been doing a lot of work in State Tree now, and I've come to grips with it. I'm one with the flow now, and the nice thing about it is that like it has a debugger that it shows the current state and it prints it out as you're going. So I can have music on and like I can just see what's happening. Yeah. And like I haven't even hooked up any audio to it. Like I mainly just want to make sure that the states are being entered and exited and stuff. So it is like it's nice. Like it makes it so much easier to like to see what's actually happening along the time. So
I think it's an implementation of the visual logger, which is just a standalone system that you can take advantage of. I did want to ask you about that though, because we did a bunch of streams centered around State Tree, or like dancing around State Tree. And I feel like what I saw what you showed this week was like you really kind of digging deep into it. And I'm sort of curious about your experience and what do you think about it? Like as a tool for audio people.
It is super powerful, especially for audio. Like we can get ourselves into like crazy systems with, I don't know, like physics or animation or just things that have a lot of different states that can be factored into a system. Uh, it's not like state tree does the same thing that you would do like in a blueprint elsewhere, but it's the way that it presents it visually in a tree. It's the way that the state kind of flows up and down the tree and stuff, that makes it more manageable.
Yeah.
Like you can put everything, get all your events, all your variables, all of your states into one display, and then just set up your logic for transitioning between them. And it's there is a learning curve, as we witnessed firsthand on
Yep.
the stream.
Yeah.
Lots of like kind of the gotchas with the magic category names and stuff. But I, it's once you accept that that's just kind of one of the quirks of the system, and you discover that it's actually pretty powerful, very powerful, I should say. And yeah, I'm gonna always kind of keep it in the back pocket for complicated setups.
Yeah.
It still wouldn't be something that I would do for like the grenade effect that I tried a while back, but
Right.
something like music especially would be really good use for it, or anything that's managing lots of different states.
Yeah. I will say, I think one of the things that I have observed about the state tree's like visual presentation is actually quite a bit of information that is given to you in like just one screen.
Mm.
And I think that's one of the things that is a big challenge in like something like blueprints or other like node or visual programming languages that are sort of node based.
Yeah.
Is this sort of like it's very difficult to sort of present a lot of information on one screen just because like a single function takes like
Mhm.
a significant chunk of your screen. Whereas like I feel like a state tree is like it's got their tasks, and then the task is like a single line
Yeah.
that's sort of slotted in like a spot that you know where they are, so you know what's going on there, and it's very consistent between
Mhm.
different states. So that's something that I noticed. And I think there are a lot of people who have fatigue over the node graphs. Like
Yeah.
yet another graph, node graph.
Yeah, it feels a
Um,
lot more like a modern approach to complicated blueprint setups.
yeah.
Um, and there's a few things that I would like to see improved on. Like most of the tasks that I made and are similar to what you made, with like it's
Yeah.
literally just like set in parameter on an audio component, right? And it's like that's all that does. And it's like, can't this just be like, can't we just call a function on a task instead of like wrapping
Oh, that's
the
interesting. Yeah.
function call inside of a task? And so it's like we have to make all these tiny little pieces in order to be able to
Right.
arrange them how we want. But
Could,
there's power in that, though.
you could do like instanced object that had its own data layout and an interface that would get called.
Mm.
Um, and so you could potentially, like I'm just saying, like in terms of like the task, you could potentially have like set parameter task that where like you have like a
Yeah.
drop down of like we actually looked at this before. I think not on the stream, but I think we looked at this idea that maybe you could do like a call a function in a parameter or something like that. There was something, I forget what it was though.
Mm.
Do you remember that? I don't know.
I don't. But
Anyway.
I'll have to look into that.
I think I agree. So in general, I feel like we're utilizing the tasks a lot like an extension of the API, and I feel like that that could be massaged to
Mm.
be a better process or more first class process or whatever. Cool. Yeah, thanks for. I'm excited. I'm glad that you.
Saw the light.
Yeah, and this is actually something that also I wanted to bring up because we've been having conversations, and I at least feel um, that we're gonna maybe do like a little bit of a format change, where uh, where we're gonna probably do less of the Iron Chef kind of thing, and more of a show and tell kind of approach to things. We're gonna try that out, and the idea, because like last time when we were, was it last time or was it the time before? I remember when we were doing the state tree thing, and I was showing my state tree implementation, and you were like heads down on something.
Yeah,
trying
I
to like
can't I can't learn state tree and have a conversation at the same time.
So I think it'd be better if when we're showing, if we're showing anything, if we have anything to show, that we are able to like just sort of focus on the person.
Yeah.
So then I can ask questions if you're showing me something, and vice versa.
Yeah, I think one of these times I would like to give another example of use cases for the Metasound view models.
Oh yeah, definitely.
Kind
And
of
I
like
think, yeah.
like the one
No, please.
example that I made the documentation page for, like the walkthrough for setting up the Metasound preset editor widgets and stuff. But they can be used for all kinds of other tools, and I think just kind of I want to open that door so people can start thinking about ways they can use it. That's not just like a knob that changes a parameter inside of a Metasound, but like you can use it for building tools that let you create new Metasounds or
Right.
manage assets at scale. So,
Well, and that's the other thing that I think I want to allow for this, like, because I have side projects, things that I'm sort of messing around with and poking at and stuff like that, and I'm sure you do too, where we can maybe show like partial progress over some period of time. And it doesn't have to be like, oh, you got to finish it by next week kind of
yeah,
thing, but like it's like the next time you have an update, like show us, like that sort of thing. And we can sort
work
of,
in progress.
yeah, keep this will help keep things a little bit looser on our end, a little bit less stressful, because we got lots going on at work regardless. So,
Yeah,
yeah,
sounds good.
yeah. So that's kind of the approach we're gonna attempt. The other thing is, I've never said this. Like, this is not just like an Unreal chat. It's just happens to be two people who work at Epic and do a lot of work in Unreal. So
It's a little bit skewed.
yeah, it's just more of a result of the people on the chat right now than anything else. So it is just tech audio chat. So there's no specific domain required, and I certainly don't want to be the like the. I think I'm probably already seeing this way, but like very Unreal. That's the Unreal person or whatever. I think actually I heard Brian Schmidt call me that once. You're the Unreal guy, right? But yeah, that's just because I've been working in Unreal for like 9 years, 5 days a week at least, sometimes more. And if you do that in anything, you'll be pretty good at the thing. Anyway, so that's a nice segue, I think, because something that. Oh yeah, actually, this is a good question. So, Eric, is there anything that you wanted to show this week, or are you just sort of?
Not this week. I haven't put together anything interesting lately, but I do have some ideas brewing. I don't have anything concrete that I'm like committing to at this moment, but I always want to try and carve out some time to do some personal projects and stuff. So I think that'd be fun to show some progress on over the coming weeks and months.
Absolutely. Yeah, I think we would all welcome that. And it could, like I said, it could be anything. If you wanted to like tackle some new thing as well, that's fine as well. I actually am reminded, this is something that I did want to give a shout out to. Just load up web page. Okay. I forgot to do a banner on this, but y'all should check out Charles
Ah.
Matthews has released an album made entirely in meta sounds. Insane. Absolutely bonkers. And the album cover are meta sound graphs. So you're looking
Oh,
at
wow.
the music, which is kind of amazing. So yeah, there you go, Charles.
I love the track names have MSS in them.
Yeah.
That's-
Iterate, stumble. Yeah, it's very descriptive of the experience. So yeah, really, yeah, check it out if it's appropriately called Rat's Nest, which is a great description.
Can you enlarge the
Oh, yeah.
artwork? If you click on it, it'll
sorry. Yeah.
it'll show the full screen, and then I don't know if you can zoom in on that if it's high res.
No, this is image in new tab. There we go. No, that's about as
Okay,
as it
well.
gets.
Yeah, you can see the nodes and stuff. Do we got any stereo mixer 8 in there?
Right here looks like could be one. I did see in a recent post, Charles, that you had been using the Tech Audio Tools thing. If I remember correctly, you were messing around with that.
Making some widgets.
Making some widgets. Widgets for Metasounds. Metasound widgets. Anyway, I think that's pretty neat. And yeah, the artist name is Skird.
Skewered.
As in skeuomorphic. Skewed.
Oh, okay.
Yeah. Oh yeah. So, anyways, speaking of, well, now I ruined my own segue.
Going back, should try and release that on Switch and release the album.
Oh yeah, you could do it as an app, like a Steam app, Charles. You could like make a little interface, pair up with like a visual, like a tech artist, and do like a visualization of your stuff. That'd be cool.
Yeah.
That's like the fun part about Metasounds is it comes with a free game engine.
Put it on mobile. I know I've seen some Metasound stuff in mobile, I think.
Oh yeah, absolutely. We had someone do a procedural album.
Yeah, that's right.
On like iOS, which is pretty cool. That was early days too. It was like 5.1 or 5.2 or something.
Yeah, I think there was a Unreal Fest talk.
Yeah. Yeah, and so speaking of non-Unreal stuff, is I have this is something I shared with. It's kind of silly, but I talked about it, I think last week. I was interested in checking out Tone.js. Tone.js is a JavaScript wrapper around web audio API, and I recently tried. I have sort of like some long-standing fantasies of like implementing some of my interactive audio systems on my website. Like I've always wanted to be, because it's always like, so before I worked at Epic, I was a freelancer for about 11 years, mostly music composition and production. But I kind of did everything. I would try to say yes to every job that I could put my hands on. But something that always bothered me was like demos were always just linear demos. Like, yeah, here's my SoundCloud link or whatever.
Yeah.
And so I always wanted to be able to put like on my website an actual like interface for playing and interacting with my music. And so I'm interested in exploring that. And Tone.js has like really good docs. You can check it out here. They've got full API docs. They've got examples, um, and it's quite extensive.
Wow.
And one of the things that it offers, which is something that Metasounds offers, which is one of the things cool about Metasounds, is it offers sample accurate timing, which is kind of amazing to consider that it's like it's JavaScript on HTML.
Does it have a UI library as well?
So the it doesn't,
Mm.
but there are like lots of web UI
Sure. You can pair it up with some
libraries.
other.
Yeah, exactly. Um, but yeah, so this is just like, here's and here's the code, and this is something that I'm going to try to do more on my website is like show the thing that I'm exploring or whatever. And this is the code for this like single tone.
Press button to play sound.
Yeah, exactly. But what's cool is that it's a synthesizer, so it's not a recording, right? So it's a synthesizer, which is like a full-on instrument object that it has. So it has like core classes and stuff, but it also has like pre-built instruments, FM, synth, and all this sort of stuff. So like full-on synth voices, and they're basically complex objects with tons of inbuilt features and stuff like that.
Nice.
So I thought that was so yeah. So that's like so it's very easy to get to. In other words, it's very easy to get to a make a sound spot. So, but yeah. So that's something I'm gonna explore, and it's something maybe eventually every once in a while I might show on this live stream personally. And I would encourage anyone who's sort of interested to check it out. It's not like it's new. It's just me discovering it, for myself. Yeah, so I want to show that. And then the other thing that I promised folks is I've got some Metasound synth percussion stuff to look at. And there are there's certain motivation behind that. Okay, yeah. So Charles says Tone.js is great, but web audio API is a lot more accessible than you think. Yeah, it seemed like there was a lot going on. But I like the idea of having some inbuilt functionality. That's kind of what I'm looking at first. But yeah, it did look like it had a lot of power. I noticed web audio API just in general, which is kind of cool. Yeah. So as you do, or as I do sometimes, I do fair amount of window shopping. It's it's that constant need to fill the void in my heart.
Oh no.
And that never is satisfied. And so I saw that one of the module manufacturers that I follow released this sort of geometric sequencer. It's got 6 channels, and then I was like, oh, I bought it because it's like I just do. But I was like, oh, I should build like a little drum skiff, like a build out little percussion section or whatever with these 6 channels. And I have already a fair number of percussion modules, but I started looking at some of the Corsynth ones. And when I was looking at the Corsynth website, I saw that they had listed block diagrams for their modules. So they have 3 modules. They have a bass drum module, they have a snare drum module, And then they have a sort of hi-hat slash metal, which is really like a 2-in-1 module. And they've got block diagrams for those as well. And so I was like, oh, that's actually kind of cool. It'd be fun to kind of recreate some of this. Some of the stuff I've seen before. For example, this 6 oscillator method of making hi-hats is something that you see in classic like 808 style hi-hat
Yeah.
designs. But I thought, oh, this would be kind of fun to recreate as best as I could. Obviously, not everything. There's not a lot of just, it's just this oscillator. So your timbre is not like, so it's sort of like up to you to interpret what that means.
Yeah.
But I could sort of roughly recreate some of these in meta sounds just to sort of see what I could get. And so that's sort of the inspiration there. And then the last is I supplemented, because it's something that I've done before in the past, but I've forgotten. Like it's there. The problem with these like I would say maybe aharmonic oscillator clusters is that you need them to have ratios that don't fit in the harmonic series. So you get this sort of metallic dissonance, resonant sound out of it. And so I supplemented it with this article I found on Web Audio, synthesizing hi-hats, and they're using that sort of the classic 6 oscillator method, and they've got a sort of starter, set of ratios to play around with. So I've put links for all of these in the description of the video. And yeah, so if you want to take a look, you can check it out yourself. And then here's the sort of preview patch that I built, scrapped together. And it's basically got all my modules, and I have like a lot of random, like just LFOs and low frequency noise that are just modulating stuff to just create chaos. And that's where you're getting a lot of constantly evolving sort of sounds. But yeah, so this is what I'm planning on going over. And I will load these up. Yeah, that sounds like you have a question.
I was gonna add. So you have like different instruments there, like the bass, drum, snare.
Back to the sort of test patch?
Yeah, let's zoom out and compare this to Charles. Yeah, there's your album cover right there.
That's right. It's I would say it's pretty modest compared to some of Charles' stuff. It was a very like fastest path to the crazy sound.
Stereo Mixer 8, I see.
Yeah, that was, I knew that I only had 5, but I was like, maybe I should go 6, and I was like, oh, I'll just go
8. I mean, yeah, it's right there, right?
Well, hey, Clara.
Hello. Could you kind of, what's your orchestration here, I guess, is the...
Oh, that's a good question, actually. Yeah, so I started with the bass drum, and I just have one. I actually started with the bass drum and the metal. So, actually, that's a good question. I could probably... Let me make these inputs. And then I can sort of... like, out of order. Just the messiest inputs. Boop. Boop.
Or organizing them.
I'm gonna put them one's out of place, just for fun. And so, yeah. So I could drop it down. So basically, what I had was first thing I did was I put the metal in, because I was trying to test this guy out, the geometric sequencer.
Yeah.
And and I'll get into the depth of the geometric sequencer the way that I built it, but basically it's a subdivision of time. So it's you give it a number of steps, which subdivides the time that you give it, and then you subdivide the steps for the hits. So you get sort of a kind of equal spacing, but you can get really interesting rhythms because, like, it's an easy pathway to very interesting polyrhythms when you pair them up. Have multiples of those in different instruments. But you can also create interesting rhythms because of the natural, the natural offset that you get when you try to subdivide, like 32 by 3. Like you're just not going to get an even spacing there, right? Because
So
integers.
for instance, here you have like 12 number of steps and then 32 total steps for both of them. So your ratios here are like 5 30 seconds and then 12 30 seconds. And are those like kind of the polyrhythms that you're layering, or like what's I mean, maybe if you just start playing it,
yeah,
we'll hear
yeah.
it.
So what? Yeah, So let me do just the metal, and you can sort of hear that metal. And actually, let me just drop this too. You can sort of hear the.
Okay.
And so if I drop this to say like 4, right, it's going to be nice even spacing. If I did something like 3, hear where it hitches, because it's dividing 32 by 3.
Gotcha.
And it's getting 10 steps for each hit.
So the remainder is kind of what's getting chopped off at the end.
Yeah.
That's cool.
And so yeah, and then if I bring in the kick drum, just bring in the kick drum here, and I'll just get rid of these. If I do something interesting like let's say 7 over 32, and then this one's 4/32, this one's gonna have a very regular rhythm. This one's probably close. Maybe it's too close. So like, I'm gonna go 12 and just. You almost have a triplet. Maybe it's none. Maybe it's not. We'll get closer. It's more sparsed out. Okay. You hear the polyrhythms that you create?
Yeah.
And then I could go even crazier if I do something like I could do 4, but let's do it in 28 steps. Oh, actually, sorry. I'm sorry.
Cool.
I did a thing that's divisible by 4. Unfortunately, that was my fault.
29.
Let's do something like let's do 13. Let's see what happens. Yeah, it's like slight off. It's like slightly off, and then you have the catch up. Because it's like flooring down to like every 3rd step, but it's subdividing the time given. So I'm giving it a whole note at 150 BPM. That's the time. So it's whatever the length of a bar is, right? Yeah. And then it's subdividing the bar. So yeah. Anyway, so it's like an interesting way to get. Let's go like 12 or something like that. Let's see.
All right, we're swashbuckling now.
Yeah, but it's not quite thirds. It's not quite triplets, right? It's a little bit off. Anyway, so that's the idea behind it, yeah. So that's how I started, was with these two, the metal and the bass drum, and then I wanted to bring the hi-hat. Actually has the block diagram for the hi-hat actually has 3 different voice modes. This was sort of interesting to me because I would have, like, because I've done a lot of these, like, these are very canonical, synth exercises, right? Like,
yeah.
Make a kick drum, make a snare drum. And the way that I've typically approached the hi-hat has been actually to combine a couple of those methods so that I get this tonal part and the noise part at the same time.
Okay.
But the block diagram has a switch, so you toggle between these different voice modes. And so it was sort of exclusive. And so then I actually ended up placing 2 hi-hats, and one being using one of the tonal ones and one using the noise mode. So yeah, and then I'm modulating the heck out of their out of their stuff. But if I were to sort of, go to like the default or whatever, something close to that, if I were to take this crazy modulation off,
You don't just hold Alt and click on your pins?
that's what I'm doing.
You're
I'm
like
just
dragging
them off. Yeah. Oh, I didn't know that you could.
Yeah, you can
click
just.
on them.
I think it's Alt. It's muscle memory at this point.
Oh, none of them are using the noise one. Did I not use any noise? One's using the ring mod. One's using the ring mod approach, and one's using the straight oscillator approach. But I could switch this one, I think, to noise.
Nice.
All right. And the hi-hat was interesting because it had separate triggers for closed and open. It actually feeds the same voice, but it feeds it to 2 different amplifiers, which is an interesting approach to the method. Yeah. So I ended up just having it on play and just making it a like non-one shot, like a continuous instrument. And then there are some modifications I made. Some of the reasons that I made those modifications were because I just they actually use an XOR gate circuit instead of traditional ring mod, but the sort of result is very similar, and so oh yeah, no, that didn't work. No, that didn't work. I'm holding on control. That was it.
There you go. Yeah, I was like,
Nice. See, there's 9 years I've worked at this.
Still learn something new every day. Just saves you a little bit of time,
That's right. So then
milliseconds.
and then I've done a snare drum very similar to this, but it was a little bit more involved. I definitely have not done this many parameters for a snare drum before, but it's a nice little snare drum, and I just set it up for. Oh, that's the other thing is I have a step offset, so you can offset the steps. So, for example, if I bring the kick drum back. So this way it's doing 2 steps, but it's not starting on the first one,
Yeah.
And yeah, so then all I did was punch in all these crazy modulators for all the parameters. I did normalize all the parameters. So that was one of the things that I felt was a good design approach. Normalizing all the input parameters allowed me to know. Well, there are some exceptions, I guess. This is technical. Some of these, there are a couple of, I should say,
bipolar.
There are a couple bipolar. Yeah, there are a couple bipolar inputs, and then I think on decay I just went with time, but I think I did map it, so it's still normalized. But yeah, that helped just attach, modulators really quick. It's just like snap, 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 snap. And I think only on a few modulators did I adjust the ranges, like here, for example. I don't remember what that was for, but I adjusted the range because I felt like, oh, 1 is just too much or whatever reason. So I should have probably copied this before I deconstructed it. I could probably see. We could test the undo buffer and see how far we get. Yeah, it's coming. It's coming along. Anyway, so yeah, so then if we whoop, just bring this back here, and we kind of see like there's like a tonal element and there's, so the head has like a tonal element and the snare has a noise element.
Yeah.
And then those two things are combined. And, and then I just gave it, we could probably go something crazy here like that. Just do like, kind of hear all the different sounds. But anyways, everything in composition that was kind of fun. Yeah.
It's like droid music.
It was, yeah.
No, that's cool.
Yeah, so let's take a look. Because some of them are quite simple. But yeah, like I said, they're based off the block diagram. So if we trace it back here, for the kick drum or the bass drum, we just have a simple sine parameter. And it's got a tune element. So you could. This is sort of nice about this kind of approach. Is you can do like a tom almost, with like a different like fundamental tune.
Always tune your bass drum.
Yeah, exactly. And then we have pitch modulation, and how much the depth of that modulation is here, and that's the bipolar one. So I made it bipolar. I don't actually remember if it was bipolar on the actual thing, but I made it bipolar because that way I could do like a uptick. So if I had like something like this, I could do like a one like that.
Oh, yeah.
And I just think there's just more sound design potential when you give yourself a little bit of that extra flexibility. So yeah, if we go back down here, we've got the pitch mod amount, and that might be a little bit. You're just traversing a larger span, and it's going to be more obvious if we extend the pitch decay. So this is the envelope that drives the pitch modulation. And so if I have less mod, I just spend more time at the lower frequencies, right? And the one thing to sort of keep in mind when you're doing sound design, like synthesis sound design, when you're trying to recreate a membranophone, which is your drums that have like a membrane, you're usually going to have some kind of pitch movement. You will have if the head is properly tuned and tight, then it'll have pitches and it'll have resonances and all sorts of cool stuff.
Mhm.
But the impact itself is going to have a kind of a pitch modulation effect. The tuning will punch a little bit, and that is where doing that gives you that recreates that sort of impact sound very nicely. And so then it's just a matter of finding, your like whatever your thing is. And then there's also an amplifier decay amount. So if you want it to like ring out. Oh, that's interesting. I've got, was it, what is that? What? Why is it resetting? That's very interesting. You see that, right?
I see.
The value is resetting. Oh, it's because... No, wait. Oh. Dummy. It's because I'm in negative pitch mod. That's why. There we go. Oh, my God. Yeah, there we go. Okay. That was funny. Okay, yeah. So let's tighten that up. I was like, what the heck is going on? There we go. Yeah. Nice. Okay. So yeah, so now you can have the amp, ring out, and that's where like you want to tune it for your like car sub. You're just shaking.
There it is.
And then it has a classic. They had a timbre. I don't know what the timbre circuit did, but I just inserted a wave shaper. And the nice thing about wave shaper, and I just went in with the cubic polynomial. But basically, the wave shaper is going to be like have some function to square your input by some amount, and then I do like a mapping here. And the only thing that what I like to do with the wave shaper when it's necessary, which you will have seen if you really review the crazy sound effects generator that we did last. Is that sometimes I will look at I'll try. Oftentimes it'll just be earballing it, but I try to get it so that my range has approximately the same power. Because when you start adding harmonics, it can increase the sense of volume, and so the balance is sometimes to try to like tamper that effect. In this case, I didn't notice it, so it was I felt like it was the same volume level. It felt like the same volume level to me, so I didn't. But that could also just be my speakers or whatever I'm listening.
Sure.
To, so yeah, I often will do this as well. Something that I will do differently. I use a sine tone to maximize the timbre difference, like the like sonic difference between no timbre and full timbre or whatever. But I often will just have a triangle wave. I feel a triangle wave is sometimes really nice. Sometimes a square wave is good, but obviously you get a lot of harmonics out of that, and there's only so much you can do to the waveform when it's square. Like it's just right.
Yeah.
So that's kind of why I went with the sine, but it does have because it's a pure tone, it is very simple. Another thing that I will often do is, which wasn't part of their circuit, interestingly enough, is I'll often put especially since I usually like to use a triangle wave, I'll often put a filter, a low pass filter, after my timbre modulator, so that I can affect something. It's something that I've heard more in like sort of so-called West Coast designs, but you have like some sort of wave folding thing, and then you need to sort of sometimes you'll have a filter or some sort of like low pass gate at the end of that, and a lot of times I like to have a filter that is driven by the amp circuit as well. So you get that almost that low pass gate effect. And that's, to me, that does two things. One is it allows the timbre to cut through on like the transient, and then it also gives you much more of a pure sound, less rumbly sound, a less noisy sound when it gets that low sub ring out. So you sort of carve out the like timbral elements, to give yourself that nice pure. Because this is the thing is like when you have sub sounds, really low frequency sounds, you don't want to crowd it with too many harmonics down there. You want to sort of give that space, especially if you're going to have other things like a bass synth and other stuff happening down there. So sometimes that could be the way to go. But your mileage may vary. This is, like I said, this is me modeling off of the Corsynth circuit. And did I bring that up? Actually, I made a little banner for them. Corsynth. It's a modular synthesizer manufacturer from Spain. Spanish company. Pretty cool. And they do stuff in the .com format, which is the format that I collect, which is absurd. It's large, sometimes called 5U. Anyway, so there's, yeah, sorry. Did you have a question?
Do you want to show us the snare next?
That's what I was going to move on to, yeah. So the snare is really like two synthesizers in one. So I I followed the voice circuit that the way they had it kind of divided. But in one you have the tonal part, that's the head. And they had an interesting design on their block diagram, and that was, and I feel like an idiot because I closed the web browser with the block diagrams in it. But basically what they had was they had two tonal like oscillators, but they actually put modulation on only one of them. But I put it on both. So that was, I think, a difference that I did. The other thing that I did differently is, well, in this case, I was looking for, again, trying to create those non-harmonic tonal relationships so that the two oscillators aren't harmonically related. I could be misremembering now. Maybe they did modulate both of them. That's gonna bother me. Anyway, I gave them different fundamental frequency ranges, and I gave them well, the offset is identical, but the tuning, they share the tuning, but they're mapped. The tuning is mapped differently, and so I had this sort of like 349 and 185 hertz. That was sort of that's where I started from, and then I just gave a range that was like 10 times below and 10 times above that.
Okay.
Sort of, and that was just an earball, I think. I don't remember I don't remember looking that up or anything. It was just one of those situations where I was like, I don't want this to be a nice division of the two, basically.
Yeah.
Pythagoras can eat it. And I just went with the two sine tones, and again, oh, this was what it was. Sorry, this is I remembered there was like something specific about one of them. Yeah. So they just had envelope, a fixed envelope generator on one of the oscillators. So in other words, this is an interesting result, kind of like what I was talking about, where you sort of carve out the timbre with like a filter or whatever. In this case, they're creating dissonance only on the impact, and so you get this dissonant relationship on the impact, but then the head rings out as a single tone. Only one oscillator persists beyond the envelope. So I thought that was an interesting way to approach that. Sort of the same thing that I was trying to do with the filter in my brain, but with an envelope generator instead. And this isn't something that the user has control over. It's just a fixed built-in thing. So it's part of their design. And so this is like some of the stuff, these numbers I kind of fudge. I'm like, I don't know, this. Whatever sounds good, you know? Because it's not an exact identical replication. It's just an approximation in this space. Yeah, so then we go into Wave Shaper, as you do. And this time I kind of kept it gentle. So I use a sine tone type, and then I only go up to 2 to double the input amount. So let me get rid of the snare sound, and we can kind of hear. Lastly, we have an envelope generator for the final output. So there's like sort of an amp output on the final bit. So we can hear. Is that coming through?
Yep.
Yeah, cool. yeah, so we could tune the head. So to me, it was that approach was much more, and this could be a failure of like it could be just because of the numbers I picked, that sort of thing.
Yeah.
But this resulted in a sound that was much more like lasery to me than like a membranophone kind
Sure.
of sound. Um, and then of course this obviously I've got full pitch mod. I did the same thing here where I do the. So some of this could be like you can certainly get those kinds of sounds out of it. This is. But you can hear how the like main oscillator rings through, and it still has that kind of strong pitched sound.
So are we hearing both halves of this? Okay.
Yeah. So no. So yeah. So you're just hearing the head part. They call it the head part, right? So we're just hearing the head right now, and this is if I lower the timbre. You can hear it's much more of a pure sine sound. Now, in terms of the ring, I was very conservative. I could have done something like a full second. If I wanted to let that sit, ring out. So some of these ranges are also earballed. I also had very tight decay curves. You can see this here, especially on the fixed one here. Those are gonna be very convex shaped. So, the slope is pretty tight at the beginning of that curve. But I feel like that's good for impact sounds. I feel like it works out nicely for impact sounds. Yeah, almost, 909 toms. Anyway, so there's the head, and then we have the snare component. And basically, it starts out with a noise, white noise going through a high-pass filter and then a low-pass filter separately. And what I found interesting was that it had modulation for the high-pass filter, which I'll run through real quick in a second. But then it also has no modulation for the low-pass filter. I thought that was interesting. No modulation for the resonance. And so yeah, and that's it. And then it just goes through an envelope generator. So starting with the high pass filter, let's see. Yeah, so let's zero out the modulation. This gets a little bit funky because basically you have a high pass cutoff starting point, and the envelope has to sort of combine with that starting point. So in this case, what I ended up doing was having the envelope generator basically sit on top of the high pass modulation. So in other words, the starting point basically of the bottom of the modulation. So like if here's your like base point, and then you're going to modulate on top of that.
Yeah.
And so all I do is I just adjust the bottom of the mapped range based on the input. So this is again normalized. So when this is full on, this envelope doesn't do anything. But when this is full down, this envelope is doing all of the work, right? So, but maybe there's some other method for combining it that has a different, effect between these two values. This is just what I ended up doing. And then the snare sound, the snares are just like metal coils that sit underneath um, the snare drum, and they add the extra sizzle sound to the effect. So I have a decay time for the movement of the high pass filter. And then you have to sort of ask yourself, which direction should the high pass filter go? So in other words, I said, here's your baseline, and then you're modulating on top of that, but maybe you want to modulate underneath that, right?
Sure.
So your adjustment has to be kind of like this sort of inversion. And so then I take a full range value, and so 0 actually comes out to the middle of this, interestingly enough. Again, a bunch of decisions that I made that aren't necessarily part of the original the design, but it was just the way that I could sort of get this working, it felt like it made sense when you were twiddling knobs and stuff like that. So then this just adjusts the cutoff range, and I just clamp it for safety's sake, because there's no indication that this is clamped, this mapping. So I was like, okay, well, we'll just clamp safety ranges. It's just a good idea in general.
Doesn't hurt.
It doesn't hurt. It doesn't hurt. Yeah, and then I just have resonance as like an option there, and I just map it from 0 to 4. And then the low pass, so I didn't even have this starting out there. So here's, oh yeah, and then I have the amp, which is the regular snare decay. So if I just ring this out, I could go long. Let's go long. We can do another 1 second one. It's just noise, right? Pretty simple. Now let's move the... So that's one way, and then the other way. It's going down to up. So what I ended up doing was, I think for my default sound, was I went down to up. I like that because I sort of conceptualized in my brain. I was like, okay, you hit it, and then the coils start jiggling, and then they calm down, right? So there's like more happening at the beginning, and so I felt like more bandwidth made more sense, and then you sort of reduce bandwidth. So that's the approach that I took with that. And then, of course, this is modulating the filter, so you go, also, though, my, range is pretty slow, so the filter is not, like, if I did this, like, really slow filter movement, we could just, like, or the opposite direction, right?
Yeah.
Anyway, so all of these thresholds are just sort of like thinking about sound design and what you're trying to achieve, and yeah. Yep. Anyway, and then so we've got resonance. If you want more, focus on that movement frequency, and then there's sort of like just a low pass. You can sort of dial in. If you just want to get. I imagine it's to get rid of some of the harshness. That's my guess. But how did I have this originally?
Don't ask me.
So that one's pretty simple. And again, these aren't crazy actually when you think about it. But then when you have them both together, we come back to, I think I had this 0.25, and I had this one at 0.5. And then it's just some balancing and finding the you know, where.
Nice.
Because really, you're just looking for that impact and then a little bit of sizzle. Anyway, so then these just route to audio that then gets mixed, and then I do on trigger. I basically trigger on the on done for each of the amp envelopes because I figure once both amp envelopes have finished, the sound itself is finished. So there you go. So that's
Nice.
that. That's the snare drum. Or were there any questions?
It sounds good to me.
Yeah. There's some flexibility. You can kind of see how you can. There's some sound design options. I think something. So actually, something that I should brought up in the bass drum. And I don't know if I would do it on the snare drum, but sometimes I like a little bit more of an impact on the. So with the snare drum, I might have considered going with maybe some triangle waves. And see how that goes. Sometimes it can sound a little synthy on its own. So, but you can sort of play around with that to give yourself a little bit more harmonic bite. And then the bass drum, something that I'll actually do on bass drums, is I will add a click. In other words, sometimes what I'll do, so like, here's this, right? And then sometimes what I'll do is I'll just add like an 80 envelope audio, something like this, where it's like 0 attack, and then I do like a really crazy fast envelope, and maybe even tight shape, and then I'll actually add it. So in other words, it's actual audio signal. And you hear that click?
Yeah.
So that, if I take it away. So sometimes what I'll do is I'll have like maybe something like this, multiply by float, and then have like a something like that in click. And then you can sort of dial in that how much of that click you want at the beginning of your sound. And that could be a nice little snap that just sort of punches up the transient on the bass drum. Sometimes I'll also put noise. If you want a more natural sounding bass drum, noise is something. Generally speaking, if you want something to sound a little bit more natural, incorporating noise is really smart. That's usually just something that you will notice, you'll observe. And so sometimes I'll put some noise in real low as part of it, just to give it kind of gives it some air and a little bit more of a fluffy sound, which is something you get from like an actual kick drum, right?
Yeah.
Okay, so let's check out the hi-hat. So the hi-hat slash metal module is actually 2 different modules. So I split it out into 2 different modules. The hi-hat module and the metal module. And the hi-hat module had the 6 oscillators. And the ratios that I'm using here are from that article that I linked in the chat. So they're like sort of unusual. Basically, what you're trying to get to is trying to avoid a lot of harmonic relationships, because that just sounds like a synth sound. But one thing that I did like about this approach. Oh, by the way, this is another thing that's kind of new in 5.6. We haven't talked about this, but you can set your variables to have default values. So no more having to have inputs when you're just trying to get like a const. You can just set a variable to have a default value. So
I have thoughts on that.
So here I set it at 1400. The article set it at 40. It was way too low sounding. Bringing it up into sort of like into bringing the fundamental up into ranges that aren't normal instrument ranges really helps sell the like metallic sound. But something that I found interesting about the approach that the article took was that you don't actually hear the fundamental. You're hearing the like the first overtone first, and you're only hearing the first overtone, the second overtone, and then everything afterwards, some like weird off, like almost the overtone, but like off, and so you get this interesting harmonic dissonance as a consequence of that. And then here's the two the two voice modes. So there's one where you just mix them together, you just sum them together, and then one where you take each pair and this was the XOR gate, but I use a ring modulator, and then you sum them together. And I just did basically I just had it's kind of cheesy way to do things, but it's like a bool comes in and I switch between the two to route the audio. So you just get one or the other. It's not if you wanted to get really finicky, you could bypass earlier or something like that. But this was a pretty easy way to set up a bypass, and this isn't like a lot more expensive to do both of these operations. Like mixing is really cheap, and ring modulator is really cheap. So it's not like there's more expense. It's just doing both of them is technically a little bit more expensive than you'd have to, but it's not a deal breaker. Anyway, and then I have a switch for the noise source. Now this is one where it's like, it's just noise. It's just white noise instead of all these oscillators, which makes more sense in a hardware circuit, but probably if you were going to do one or the other exclusively, then I would probably split these out into different, maybe make this a patch or something like that.
Like break it up a bit.
Yeah, break it up somehow, so that you have different implementations for just each voice mode. That would be sort of a more practical approach to this, but yeah, I was still on that sort of like recreating the circuit thing. And then then we do a lot. So we go through a bandpass filter. So I just grabbed the biquad, and I have sort of some approximation of resonance and the cutoff input, and then we have again a low pass filter following the bandpass, and then I think both cases. This is my guess. I think in both cases, Corsynth added this to sort of allow you to remove some of the harshness from the sound, because obviously like very harsh metallic sounds could get grating, and so sometimes you just want that sort of mix power to sort of like take some top off the a little bit off the top. Anyway, that's my guess for why I see this pattern a lot in their stuff. Anyway, moving along, we've got the amp envelope with a decay and an interesting little thing here. Another amp envelope. And so actually, now I forgot why I did this. This is in the diagram. Well, right. So it's oh, that's right. Right. So this is these two amp envelopes are the closed hi-hat and the open hi-hat.
Okay.
So it's the same voice. So in other words, you're just rendering the same audio and you're just choosing one or the other. The only thing that I did differently is I added this bit right here. And the idea here is that this closes this. So in other words, it was a sort of my like loose attempt at a choke on the open hat. That's all. That's all it does. And it just helps to have that close, because otherwise the open hat is like ringing out through the
There's like two voices, kind of.
Yeah, exactly. So that was the only difference. That's what I added, to that. Otherwise, very similar. And then I just did an any. I did an any So if I wanted to treat it as a one shot, I could, and it would just be like closed. I would either trigger the close or trigger the high or the opener, that one or the other basically, and it would just be a one shot. But yeah, so let's make sure we're in we've got the ring mod mode. Let's take this off. Let's go pure, no noise. So here's yeah. So now we're rolling, and then where's my trigger for the closed? Here we go. The closed. Oh, let me try. I forgot.
Turn off, yeah.
Yeah. Let me just get rid of this real quick. I'll just kill it. Anyway, so there's. So that's the 6 oscillators. It's not bad. It's very metallic, right? If I add some reverb to this, it'd sound nice. And then the open's a little bit more revealing. Obviously, that is quite tonal, right? Now, if we switch to ring mod route, boop. So now we're going to hear this part, and it's going to be very similar, right? But we get more of that lack of tonal relationship, right? Because the ring mod basically skews your harmonic content around. So it's a great way to sort of create that like metallic sound. And again, that's very metallic resonance is a little bit excessive, right? And this is one of the things that you'll notice I also did here is I had a very sharp decay curve. And that was the idea. The reason I did that was because I really wanted the attack, that first transient to pop out when compared to the rest of it. So the really sharp amp curve. Because otherwise it just sounded like a synth sound, Yeah. And this could almost be like a triangle or something like that. But
yeah, the clean one sounded very much like a triangle.
Yeah, like a tuned triangle.
Yeah.
Yeah. Now, if I switch to the noise source, then yeah, we've got but it's very dull, right? It's very dull. And then very similar, but it's just okay. Now, my approach would be to combine these. I would probably mix and match stuff. I like to have the tonal. I like to especially have that metallic hit at the beginning, the tonal metallic hit at the beginning, and then I like to have that noise ring out a little bit on top of that. And I think if you take these 3 methods, you can kind of mix and match them to create like a really convincing hi-hat if you wanted to. But anyways, this was just sort of the way the circuit was set up. It was like these switches, these hard toggle switches. But yeah, so that's the hi-hat. And so it looks more complicated really than it is.
Yeah.
Once you go through it. And that's just because it sort of starts with this sort of 6 oscillator design. And then obviously I've done a lot to sort of dial in what I felt was like a good default for all of these parameters. But these aren't modulated in here, at least, These are just static. A lot of this stuff is like we saw like lots more movement in terms of like filter movement and pitch movement in other patches here. And here we don't do any of that. So I find that kind of interesting as well. It's just these two the only envelope generators here are modulating the amplitude. That's it. So finally, the metal patch oh, actually I should stop. Oh no, I did stop. Okay. Finally, the metal patch is simplified. This time I used square waves, and that was to bring out that metallic sound. But you can kind of see what we're going at. We're going right into a ring modulator to get that metal resonance. And our pitch relationship. Oh, this was the one that I was misremembering it. This was the one that I remember there was a pitch mod that one was static and one was not. And so here I have a tuning range that is just, you know, probably only incidentally ever going to match the harmonics of this. You know, it's only by accident could you tune it in. It's just this normalized value going through this map. And then we have a band pass. So we sort of carve away some of the harmonics again. It's this is driven by an LFO. In this case, did I do? Yeah.
Can we hear this one again?
So, because the ring mod, you can get some really interesting metallic resonances by just modulating the pitch of one of the modulator. So there's a lot of just sound design opportunity just there, you know.
Yeah.
And then here, what I did is I kind of mapped this LFO, but as like a decay value, sort of a different way of using it's because it's a saw wave, so it's technically it's like an envelope generator.
Yeah.
Yeah. And then that's just going to the filter cutoff. And then you have decay is also being used on the amplitude, right? So, in other words, this is going to like modulate this filter quickly or otherwise. And it was just a way to create a relationship between these two values. I don't remember if this is something I added. I think this was part of the original diagram, but it wasn't clear how these related. So I just plugged it in, you know?
As you do, yeah.
Yeah, exactly. Oh, yeah, and so here's without the mod. So it created some movement. I don't know. It's subtle. Part of it is also that we don't have like audio rate filter modulation. So just it's very difficult to do that in the anyway. So you can get some nice, like, you can kind of hear how it's like the band passes is like carving into, like, you get that nice starting pop transient and then, yeah. It's almost like a bell, like a hotel bell or something like that. Anyway, so this is there's just a lot here to play around with, you know. And again, it's just sound design options. Very simple design. I think you get a lot out of this. 2 square waves, a ring modulator, filter, envelope generator. Like, that's it. And then I just sort of, I did like a gain compensation because it was like coming out really, really quiet. So this is just something I added to the circuit. So yeah, that's those are the 4. And now, oh sorry, did you have a question?
I'm just ready for the final performance. Let's hear it all together again.
Well, actually, also remember, there's also my sequencer.
Oh,
we
that's
kind of
right,
already
yeah.
described the sequencer, but the way that it works is I bring in time, the time value, and the total steps, and I always protect against divisions by 0.
Yeah.
So I just sort of I use the max. So this value has to be 1 or above, or it won't pass through. And so this will always be at least 1 subdivision. And then I pass it into the period, and then I get So in other words, if this is like 1 second and then this is like 32 steps, then this is 1/32. The period is 1/32 of a second. Maybe that wasn't a good example because I said second twice there. If this was 16 steps, then this would be 1/16 of a second. Anyway, then it triggers out, and I just go through a counter. The counter is set to reset at the total steps given. I take the value, which starts at 0. The counter count output starts at 1. This is a good thing to know.
Yeah.
The value starts at 0 because its start value is set to 0 here, and I just floor it to a integer. So I just convert that to an integer. So I could also do a count -1. That would also be okay. That would work. Then I just add the number of offset steps, and then I do a modulus. Doing this properly is probably a little bit more complicated. But this was like an easy way to just create an offset, a starting offset. And then I put a modulus in there. And then what I do is I take the total steps and then I divide it by the number of steps. And that creates my reset. And so in other words, if I have 16 steps, but I'm doing like 2 hits, like two hits for the total number of steps, then I want it to go every 8. So I take the total steps, 16 divided by 2, I get 8. 8 is the modulo value, and then I compare that to 0. And when it's 0, I pass the trigger through. Okay,
Nice.
that's how it works. And
Easy peasy.
Yeah, easy peasy. Easy peasy. And I really messed around with stuff. I forgot what I don't know what I messed around with, but I clearly, anyway. What we can do is we'll just create a new one here. If I can find it. There we go. My new song. There we go.
Hopefully the patches will still cooperate.
Oh, they'll be fine. Who knows what I did wrong. I added a value to one of them. So that's dangerous. I have run into a bug that I haven't reported yet. That was an interesting bug. Let me close these. Just in case. Boop. Here we go. And this song never ends. Get our classic mono mixer 8. Why not? Let's go.
Go big or go home.
Go big or go home. And then we go our bass drum. So kind of like how we had it before, where it's like, oh, right. Sorry. Let's put our sequencer in there. Sequencer. Here we are. And then let's go BPM to seconds and make that a nice little thing we can mess around with. So yeah, right out of the bat we got, sorry, let's do this 1 bar. That was quarter notes. There we go. And then I could just sort of create a bunch of inputs here. Oh, I added that click. That's right. I forgot about that. Boom. There's our amp decay. Our pitch. Let's put the tune over here. The timbre we'll put right here. There's amp. Pitch mod. And then click. So then cool. And then we could add our, I could just copy this actually. I could just go boop. Boop. Add our metal. This is kind of how I started the last one, right?
Yeah.
Yeah. And then we could go, let's put 12 in there. bring that down. Strong sound. But then we could also add some movement. Let's get some low frequency noise, and we could just pop that into the decay. Just already have some variation. We could let's copy this. There we go. And we'll bring this into the tune. That's pretty wacky. We'll slow that down first of all, and then let's constrain the values. Let's say we go from 0.5 to we like the sort of higher ones. So let's go 0.8 to 1. Let's just see what that. The other thing that we could do, actually, I realize what we could do here is we could do a random float every time, and then we could get some then it doesn't sound like it's like a radio.
Yeah.
We just get some variation on the
hits themselves.
The hits, yeah. And then we can probably squeeze that in. Yeah. Let's go 0.9. Just go a really tight range. It's a little bit random computer sound right now, but let's add another one of these. And we'll make this one. It's just more full range here, and just sort of see what this does. You know what? I'm gonna add a little bit of noise to this. Let's So what we'll do is we'll go 0 to 0.1, and then we'll add the values together. So there will be some movement. That's too much. That's too much. Let's go 0.05. Let's go 0.02. Real. So there's some movement there, but it's a little bit different. It's like a different kind of thing.
Should do some rhythmic variety now.
Yeah. So what I could do is with this one is I could do something like, where it's like 6.
Could modulate that too if you wanted to speed up and slow down every so often.
Yeah, that's interesting.
Or,
try that.
I don't know. Trying to stir the pot a bit.
Excuse me. And then we'll go 0. Maybe we'll go. Hold on. Let me think of this. Is this dangerous?
I was gonna say just pick a new number of steps every so often.
The thing, yeah, I just want to make sure. Oh yeah. I was spelling out integer, so it was giving me. You mean enter? What was I gonna say? It's just all I'm concerned about is any expectations about the range of values coming in, and I think it should be okay.
You have a clamp to 1, right? Because you had the max 1.
Yeah, yeah. Let's go something like this. Let's see what happens. That's
nice.
Cool.
Yeah, I'm down. Yeah. It's more like phrases now.
Yeah. Oh, the other thing that I did was I did 5. I don't know if that does anything. We'll see. Oh, different kind of thing going on.
Nice.
And we could add some. This is where we could add some again, like instead of these, we could go back to having some like low frequency noise, and then just go straight into that. Go, okay, we'll do that and that, and one of these.
Why not? Nice.
Oh, Claire is asking if there's a way to do like a stepper. Yeah, so what you can do with the noise is you can control the step limit. So in other words, this is like the potential, like the differential, and so you could constrain it. So like for example, if I was like I only want it to move a tenth of a step, then it's gonna constrain its movement. So then you'll get, that's nice because then you'll get random movement, but it'll be like, subtler shifts in values. And then you can kind of randomize that itself with the rate. So like here we have it at 5 hertz, but we could, add some looseness to that frequency. Low frequency noise, don't sleep on it. It's good. It's a good and then we could do grab this here, and then we could get our snare. Is it snare drum? And so out of the box, it's going to be with our kick drum, but we could offset it. Right?
Yeah.
And then we could maybe reduce it. We could go like 3 maybe instead. So, yeah, I think I'll go with 2. Just sort of see. That's a regular. That's like brings in the, like every comedy act needs a straight man. Like, kind of, like,
Yeah, you gotta lock in,
Yeah, exactly. Anyway, yeah. So I mean, that's just
But the hi-hat.
Oh, okay. I see.
Even crazier.
We could do is something like. Okay, I guess.
Need some cowbell.
Well, you could almost get a cowbell with some of the like the metallic.
Yeah,
right?
I was
Like
hearing it earlier. I was like, dang, that's
like
like be a cowbell.
You got to get that like sort of deeper tone, so that you have to play around with it. Probably changing the fundamental of that one oscillator, that sort of fixed oscillator, to bring that down a little bit. I think you could do it. And then I think also what might help is sort of similar to the membranophone. If you add just a little bit of a pitch mod on it, might help as well. Okay. Oop. Oh, right. This one. Oh, yeah. One of the things that I did. Sorry. Actually, something that I didn't talk about this. One of the things that I did was, as I used the trigger filter.
Nice.
So, in other words, this just grabs the on play because you just try to start it up, and then I used the
perfect.
The trigger filter to decide, and then I was just like, oh, I favor the closed hi-hat, more than the open hi-hat. And then we could do something like 18. Why should this be 0?
Nice.
Yeah. We'll get. Let's bring in a low frequency noise, and then we could just sort of go crazy with this. What I could probably do is create like a like low frequency noise cluster or something like that, like a patch that's just like a lot of low frequency noise or
Yeah.
something, and then
Save some
just
space.
yeah, save some space. Anyway, let's.
That's cool.
Yeah. And then we could just bring in like a fat saw ladder filter, classic ladder filter. Let's make a little bass sound. Let's bring it over here. I'm gonna make my bass sound over here. You don't want to put the bass player too close to the drums. Let's go with, nope, that's not what I wanted. Let's get the sequencer. Okay. And then our BPM time. And float array. So I'm going to use this. I'm going to quickly grab from a random float array, which is going to be a scale to note array. And then we'll have add, pure add, offset by 36 values. Then we will convert this MIDI to frequency. That's going to be the fundamental of our saw wave, and it will act as a 80 envelope float. 80 envelope audio. Okay, and then what we're going to do is we're going to go map. Float map. Float the map. This will be the bottom range. We'll go 4,000. We'll add a little bit of touch of resonance. And then we will multiply this by this. And then we will go variable. By the way, I have like a naming convention. So this is an audio type variable base. That's how I do naming.
Interesting.
I think. Okay, right. I wanted to do. I don't want to change it. I don't want to break it. So here's what I'll do: is I'll do this. Capture. Set this, and then we'll reset, and then we'll just make our number of steps the same as the let's do 5, but we'll do the offset like we did before. 2, and then we'll go 4, and we'll just see how that sounds, and then we'll go like that, and then we'll go 0.25. So we've got sharp curve for the cutoff. Okay, so then we could do, there's a couple things we can do. One, we could obviously make our BPM a lot more aggressive.
Yeah.
Maybe it's a little bit too much. But the other thing that we could do is, bring it to 95. There, we'll go 95. What we could do is we could add a. Oh, I guess it wouldn't matter. It's just I forgot to. This isn't a stereo patch. Oh, just a delay. There we go. Oh, that's. Oh, oops, that's the wrong one. Delay time. Let's go, and then let's go here. And we'll grab something like 3. See what that gets us. And half feedback. They're still okay. Anyway, yeah, so that's
Nice work. It's cool seeing you like in the flow state, you know.
yeah, it is.
You've
That's
done
something
this a
that
few times.
I have to. Yeah, you can tell I'm sort of familiar with stuff. Well, and that's something that, like, you know, I hope these kinds of deep dives can sort of show you, like, give you a framework, like, to start out, you know, something,
Yeah.
and then it's just having fun and sort of experimentation. That's something that I think is maybe not. I think for some people might be intimidating. Is that you definitely want to experiment, and I think that, like, if you get into a sort of headspace where you're more open to just trying out something and just
Yeah.
being willing to fail and all that sort of stuff, then I think you'll enjoy it more, and I think you'll come up with more. And I think they're a big part of something that I enjoy about, even with someone, even having the experience that I have with synthesis, is that there's almost always something to discover. Like, I sometimes I'm like, I'm pretty sure I know what's gonna happen, whereas, like, sometimes it surprises me, you know, or
Yeah.
or I
Happy
sort of,
accidents.
yeah, exactly. And I think that's the fun of the work itself, and it's something that you won't ever get, like VST surfing, right? Like
Yeah.
the VST surfing will always bring you back to the same thing that someone else did. And yeah, the only thing that I will say is advice that I heard from Hans Zimmer, which is, and I'm not going to say exactly what he said, but basically it's like, if you want the sound that you create to work with something, you have to do it in context. It's obvious when you, like, think about it, but it's easy to get lost, to sort of detach yourself from the greater context of whatever you're trying to achieve, right?
Yeah.
And so you kind of have to always bring it back to that thing. And I think that will be that, because like the exploration and the discovery process, that gives you a lot of crazy vectors to traverse. But if there's something you're trying to achieve, some specific result that you're trying to conclude to, then I think you have to kind of always bring it back to that, whatever the context is. If it's a song, if it's some project you're working on, some experience, and sometimes it's even the space. Like if you're more of like you're creating art installation or you're a performer or something like that, sometimes it helps just to hear it in this space that you know you're going to perform it in or it's going to be presented in. So
100%.
yeah. Cool. Let's see. Right. There you go. I forgot to put this one up. Take care of yourself. I'm adding banners. I get to add banners.
It's like newsflash.
Newsflash. You're important. Value yourself. Hydrate.
It's too much power.
It's too
you
much
have
power.
you have too much power now.
And yeah, and this is something that is a joke that we made earlier, and that's live streams go-to tea rooms. Perennial Tea Room. We're not endorsed by Perennial Tea Room. Just shop there. It's awesome.
Drink a lot of tea.
I drink too much tea, and so I'm a regular customer of the Perennial Tea Room, Seattle's premier tea spot.
Yeah, they're down in Pike Place.
Yeah, they're just off the beaten path in Pike's Place. It's cute little alley. I forget what it's called. It's got a name. It's like, should I go down here? And then you're like, is this like some magical alley? Like, why are these weird shops? That's kind of cool. And then you go. Awesome tea. Yeah. We had a good chat. It was robust. I wasn't even paying attention, though.
You were in the zone.
I was kind of in the zone, yeah. Oh, yeah. Yeah. Oh, that's actually... So, Steven brings up something about the modules to recreate, and that is that it does help sometimes to have inspiration. There's actually a really great book that I recommend to anyone who wants to dig into synthesis and synth design. And I want to make sure that I remember. I'm looking it up right now because I want to make sure. Yeah, because it's got... Okay, so it's called Patch and Tweak, and it has 3 types, 3 flavors of the book. It's just called Patch and Tweak. I have the exploring modular synthesis, but they have like a Moog edition and they have a Korg edition.
Oh, okay.
So you can check it out. But yeah, Patch and Tweak is like an awesome compilation and history sort of anthology. It goes over like the history of various synthesizers, different... It's like almost like an encyclopedia in some ways. Like it's like a reference to different modules and different types of modules and all sort of stuff. And then it also goes into like patches, like popular patches throughout history, kind of thing. And so it's definitely something that I would recommend if anyone wants to. Again, no endorsement. That's fine. We don't need money for this. Pay it forward. If you like this sort of thing, the stream, stream. Do your own stream, or teach someone else something, or just demonstrate something, or just show off something, or just do whatever you want, because it's your life. And that's gonna be my send off from now on. Do whatever you want. It's your life.
It's a good one. Good rules to live by.
Goodness. Were there any forgotten banners? I kind of just, yeah. No, we did all of them. Except for this one. This one we've done before, but just like, that's fine.
All right. Well, until next
Yep.
time.
Yeah. See y'all.